Hey, what is up, guys? Just a quick note. I know I uploaded studying number 6 today. That was, I think, either last night or 2 nights ago. Um, I just forgot to upload it. So now I'm studying tonight, the day, 7-11. Um, and it is late at night. I have messed up. I should have studied this earlier. It's actually not bad. I reviewed it like this morning before work, and I was like, oh, it's not too bad. Um, and I think I did the workbook problems with you guys in number 6, and honestly, it wasn't too bad. It wasn't as like thrown into the middle of the ocean as the section 1, week 1 and 2 workbook. So it's it actually feels nice to kind of have some understanding. But because of that, I procrastinated and went to go play pickleball. And now it's goddamn 11:10, 11:09. This is due at midnight. I'm just like, I haven't even showered. And yeah, I know you guys came here for math, but I just wanted to vent a little. Honestly, if I was younger, I would not be here. I would not be doing this homework. I would be in bed, sleeping. But I guess this is being an adult, taking responsibility, and when shit needs to get done, get it done. So, enough blabber. Let's get to work. Also, I apologize that I've tried showing you guys this monitor too, where I'm having the calculator shown and the graphing software Desmos, but it just fries the recording and I can't. It just doesn't record. So I'm sorry. So this is obviously I think, since it's 0, it's -2. Well, I know actually, how do I have to, oh, maybe I should have printed this out. So I had a screenshot of your graph, and either grade will be based on completion. Repeat the estimated to construct a function in this graph. Okay, oh, my bad, guys. Okay, let me print. I don't need to print out this. Okay, let me print this out real quick. Sorry, and then I'll be right back with you guys. Okay, I'm back. So what I'm thinking is it's either sine or cosine, but I'm unsure right now how to decide because I thought the only difference between sine and cosine is that sine starts so sine is like this, starting from 0, because sine of 2 pi or 0 is 0. And then cosine starting at 0 is 1. But I thought it was like the same shape after that. And so I was like, okay, is it just sine? Is it just -2, in the sine? So sine of -2 theta, is it like that? So, or is it like cosine instead of it's 0, like plus, like a vertical shift or something? We haven't seen that yet, but so let me get out Desmos. I'm going to do sine of theta. Okay. Try adding r equals. Okay. R equals. No, that gives me a circle. I would like. Okay, what about y equals? There we go. Okay. So sine starts here. Let's do y equals cosine. I'm just in Desmos putting out a sine and a cosine. Yeah, it looks the same, except just technically just shifted. A cosine is just shifted, or I guess either way, just both are shifted a bit. Okay, so how would I get this one where the amplitude is periodic, remember that's half the difference. Oh no. So amplitude is just 3, if I'm not mistaken. Because -2 to 1 is 3, -2 to -5 is 3. And then the period is just pi, since it returns back to its original state. Oh. after making one full rotation. Yeah, pi per pi. So estimate the amplitude. The amplitude 3. Can you just write 3? Do you have to like say something equals 3? And then the period is pi. And then construct a function. Use graph. Oh, graph your function using Desmos. Okay, so I should just fuck. I don't know how I'm supposed to like just mind fuck this. Without Desmos. Like if it like I just went into Pre-Calc 1 and we learned how to deconstruct a graph, you know, where's the vertex if it's for quadratic, where's the x and y intercept, you know, what's some of, you know, what's if it's a rational function, you know, what's the degree over degree ratio, yada yada. But I'm not familiar with it with sine or cosine. You know, maybe. Okay, if it was cosine, it would have to be both multiplied by -2 to bring it down here, or I know we did it in the workbook. The thing inside the parentheses with the theta, does that affect the? I think it affects both. No. The radius, y, or yeah, the radius is the amplitude, and what's inside determines the period. So yeah, you know, I'm gonna use that. I don't know how he wants, like, even if I had a hypothesis, so let's say I think about it a long time, I would, yeah, I guess that is what he wants me to do. Okay. So yeah, my hypothesis is both sine and cosine could get to look like this graph. It seems like you would just have to do more to cosine because you would have to make the amplitude different, which you do have to do for both sine and cosine. But for cosine, you would have to shift it because you guys can't see, but cosine starts at peak at 0, 1. Sine starts its ascent, or does the second half of its ascent from the previous trough at the y-intercept. So you really only have to do the amplitude, same as cosine, but a vertical shift, I'm pretty sure. And then you would have to do. Okay, so cosine. Okay, so they're the same number of steps. Just sine, you would have to do a vertical shift, and cosine, you would have to do a horizontal shift. Let's test that out. So let's do sine. Okay, how would you get it down to -2? Let's just do -2. I wonder if that. Oh, there we go. Okay, and now you make it twice as fast. So you do 2 theta. Let's see if this. Okay, it says it reaches. Oh no, actually this should be higher. So did I have to put like 3 as y? Oh no, I went away. How do I tell this? How do I tell Desmos what the amplitude is? Yeah, I kept the amplitude the same here. Maybe it's 2 times. Oh, there we go. Okay, so it's not 2 plus, no. So whatever is timesing the sine, or the trig function, outside of the theta parentheses, apparently affects the amplitude in a y equals function setup. But if you had this circle circle radius as a context, that would just stand in. Okay, so 2. What was it? My amplitude was 3. So 3. Oh, there we go. 3. -2. At 1, it's between pi half. Oh, at 1 it is pi half. It's so where does this complete full rotation? Oh, it's giving the x. Desmos is giving the x in. Yeah, it did. Okay, so this has to be moved faster. Oh, I removed the 2. Oh, there we go. Powerful. Okay. So this one is y equals 3 times sine, and the 3 is determining the amplitude. Inside the sine is 2 theta. The 2 multiplying the theta is doing the period acceleration by a factor of 2. And then you have a vertical shift of -2 to start it at -2. Now I bet we can get the cosine also there. So let's see, I'm just gonna minus, let's see, no, I'm gonna plus, no, I want a horizontal shift. So I'm gonna try, just from Pre-Calc 1, let's see if this works. Inside the parentheses, I'm gonna do plus. Let's start here. Okay, cosine, let's start its peak there. So to get it to look like a sine, -2, no, -1. And if you want to go left, you actually +1. So +1, oh, there we go. Okay, now let's do -2 times, oh wait, I didn't do that right. Oh, I also have to -2 outside the sine. That's not looking right. Still not looking right. It's close. Maybe 1.5. What is that? It's kind of closer. It's still not looking exactly like a sine. Maybe I'll pull this over 3 times. Yeah, it's actually, look, I'm doing the, okay, so there was more steps. There was more steps with the cosine. I had to do both the vertical shift and a horizontal shift, and it honestly still didn't get it. So I didn't get this factor right. Let's see, is it 1.7? Let me see if that was too far. It seemed too far. Or maybe 1.5. Okay, that's close. Oh, I seem to have. Oh. It seems to be the. Huh, maybe sine. Okay, let's do the exact same thing to cosine as I did to sine. Okay. If you do the same exact thing to sine and cosine, you would just see the differences that you started with the regular sine and cosine. Makes sense. But cosine is starting at 1. Sine is interesting that this isn't. Oh, cosine is. Oh no, here it's here. Huh. Doesn't seem like the 3 times is doing it. Oh yeah, why isn't the -2? Huh. So the 3 times, well, if you just roughly evaluate it, cosine of just theta being 0 is 1, and then times 2 is, somehow it's just, this is getting to be 1, and then maybe it's multiplied by 3 to get 3 is the y, but maybe for cosine, multiplying by 3 is like the vertical shift up here. Let's remove this. -2. Look, like if I remove this, it should still be at -2 at its starting point. Yeah. Okay, here's that shift. Okay, so -2. Oh, sorry, 3 times. And I'm tired. cosine can't do it. No, I feel like cosine, if you mess with it enough, would be able to. Here, let's do it. Just make it, okay, you want a plus 1. No, you want a minus 1. Oh no, this is actually not 1. This is pi over 4. Cosine minus pi over 4. Oh. Maybe trig functions are different. I thought from Pre-Calc 1 that when you have a function like x squared minus 2, the minus 2, or yeah, the minus 2 actually is vertical, but if you had x minus 2 all in a parentheses squared, that inside the parentheses is a horizontal shift, and that minus 2 unintuitively shifts it to the plus, and that vice versa, the plus inside the parentheses would shift it to the left. But it seems to not be the case here, because I just minused. And it, oh no, it did do that. Minus. And I can't remember what it was at before. Okay, it's at 1, 0. It has the same amplitude. Barely moved. Why did it only do pi? This is pi divided by 8. Even though because cosine, because maybe the change in x for pi over, the change of x of pi over 4 is not going to be equivalent to the change over x of the equivalent angle, the equivalent radian for sine, because as we showed with the unit circle, it's a different rate of change at each point. You know, at some point it's going up faster, at some point it's doing more horizontal faster. Okay, so I'm going to say it's possible, just because, you know, probably good enough to rule it out, but I don't know how to do it. So how does it match up? So we're going to delete the cosine. Actually, we should write that down. Can cosine look exactly like sine graph? I tried to adjust. This is, I met with the professor. Let me write this and I'll tell you guys. With various transformations to get close, but no cigar. He's a bowler. he seems very good at his job, which is so refreshing from the last professor was just, he seems like an actual knowledgeable guy about mathematics, and he seems eager to teach. Yeah, he gave a good impression, and he answered my question very well. It was an easy one, but you know, I'm looking forward to asking the rest of the questions with him. I came late to the office hours, like last 10 minutes, because I was finishing up something at work. But yeah, I'm excited. I'm going to see him tomorrow. It's so late though. It's at 7 p.m. I go to bed at 8. So yeah, but here's it's a good guy. Good sesh. Okay, graph your function using test. How does it match up? Exactly. And I'll put what I put y equals 3 times sine 2 theta minus 2. Repeat the above with the 2 graphs below. Watch out for the second one. I was thinking about this, I think in the car, because I was already like trying to preload some of the cognitive work I was going to be doing on the car ride home from racquetball. And I was like, this is probably exponential to the theta. Yeah, okay, let's do this one. This one is looking like cosine because the peak, granted it's it's an opposite peak, but it is a peak at the y-intercept. So let's try y equals cosine theta. Okay. You see that the amplitude is, let's see, it's -1 and 4. So 2 to -1 is 3, 1.5 to 4 is 2.5. 1.5 to -1 is, I think, 2.5. Okay, let's see. Amplitude. Oh, we showed that negative, that multiplying. Oh, no, it does. Looks very different. I'm sure that was. I can just. Work smarter, not her. Oh, because I did the minus in there. Does that look? -2.5, no. And it goes, this is, no, maybe it's more. Maybe it's -3. And then plus something, or +2. Okay, so it goes down to -1 and then it goes, and this is going to 5, so this should be -2. Good lord. I'm not thinking here, I'm just plugging and playing, which is probably not very good, but +1 maybe. Until, then I want it to 3 instead of 4. Okay, let's do minus, come on, I got so close. If I did +1, it'd be -3, not +2. See, why is it, oh, it shifts the whole thing up. Okay, so it's in between 3 and 2, if I'm not mistaken. What's the difference? What's 5 up? Yeah, it's 2.5. -1.5 or +1.5. Oh, there we go. You're sneaky. Okay. And it looks very fast. It's completing it right before 2. Pretty sure pi is 2 pi, no, pi is 3.14. Okay, let's try like 3. Oh. Okay, where's this completing? Right after 2. Oh, it's even faster than that. Let's try 4. Okay, this is looking a little closer. Oh, you guys aren't seeing one. Down here now. See? Oh, it's right before 2. Looking from here to here, completing a full range of motion. Okay, I can probably delete this now. Right before 2. This is kind of right before 2. It's right after the 1/2, which I think this is. Yeah, it's right after it. Pi over 2. Oh, okay. Pi divided by 2. 1 point. Okay, right after 5. Right after 1.5. And it'll end. What's this for, like 3? 3.5, 3, 3.54. Right after 3, which would make sense. 3.14. Okay. Perfect. Okay, so I got that the same. Okay. -1, 4, range of amplitude, range. Starts at -1. Okay. Oh boy. Okay. This is y equals -2. sure that transformations seem to affect cosine differently than sine. Okay, yeah, let's. Okay, and this one starts as a cosine for sure. Well, using from what we know about the cosine having its peak at the y-axis versus the sine having the middle of its ascent and the x-axis. So let's try sine of theta, and let's try to. Let's first try to. Yeah, it starts at 0. Oh, okay, so -1. Start it there. And then we want it to increase. I'll show you guys now here. Doesn't that look? Because if we're already using multiplication inside the parentheses to get us an amplitude. Oh, we're not. It's actually outside. Inside is. Wait, let me. Oh, inside is speed. Okay, so maybe it's squared outside. So like x squared, or just maybe something squared, like 2. Oh, no. Okay, so maybe that's x squared. Okay, let's try x squared times. Oh, that's not gonna work. All right, let's try cosine squared. Maybe theta squared. Okay, it does seem to get interesting. What about outside? Oh, this one. Yeah. All right, what if you had? I think it's like if multiplication is making the period expand, making the amplitude expand, then an exponent in the same place as where the amplitude is usually transformed, doing the transforming, that would make sense because not sure where, but this is kind of similar. This looked like looked like the rate of change that we're looking for. This seems to be getting, yeah. But this one's amplitude itself seems to be increasing, while this, okay, yeah, that would make sense because inside is period. So maybe it's y squared. No, that wouldn't make sense. Okay, what about factorial? No, it's just a constant that will be multiplied. What about 3 squared? No. Okay, what represents? What if it's another? Oh, that'd be interesting. What if it's another? It's too late. What? Like 2 squared? No, because then it's like. Okay, what about here? Oh, come on. Oh. Okay, what about z? Maybe x doesn't like to play. Right? Like, look at that. Doesn't that look like... actually, no, because once you set it as a static, the whole thing sets as like that, like amplitude. But if you look here, the amplitude is increasing. How do you have something increase on itself? Usually it's exponents. What if it's like a sign? Like, what if it's another? What if it's like another trig function? Oh, this looks messy. Inside. Oh, that's just wonky. That's not right. Actually, and it's flipped. You know that. Look. I should get it at 0 actually, and I want this at. I want it at +1 actually. Like that. It does a little bit. Okay, what if I did like -0.25? No, that doesn't. Any ideas, guys? Square root cosine. Yeah, so we can only just try. I don't think so, but yeah, let's try. This is interesting. This is really interesting, actually. I'd love to explore this another time. Okay. I don't know what to infer from what I get when I do something to the whole of the cosine part. Like, when I'm multiplying, it changes the amplitude. When I did the square root, it added domain. The amplitude itself increases. Oh, what if you did cosine times cosine? Cosine? Yeah. Oh. Okay, so 1.7. Okay, so I think it's a bit faster. But I still don't see that increase that I wanted to see. Fuck me. Amplitude has to increase throughout the graph. So as you increase x, absolute value. As you increase or decrease x. As the this is reminding me of distance formula. As the distance from 0, as x's distance from 0 increases, the amplitude increases. How do I represent that? Y equals something doing to x. And I want to represent that as x increases. I think that's absolute value. Oh, I need to remove this. Huh. Interesting. Kind of the bowls almost, but not what I'm looking for. Fuck, I could have. Oh, that'd be cool. What about AB? Let's try this. AB. Nope, that doesn't work. What about pi? Nope. What about pi raised to? Yeah. That's a constant. Okay. As. How would I put that? As x's distance from 0 increases, amplitude increases. Okay, let's plot out a chart of easy ones. So at 0, it's 0. At, what's that, 1? 1, 2, 3, 4, 5, yeah. So at 1, of x being 1 or negative 1, you have 1. Okay, negative 1, 1. Okay, if you have negative 1 to 1, every time you, this x's distance from O increases, amplitude increases. I feel like that makes it not periodic. Like, doesn't periodic mean that it's constrained as an amplitude, but this amplitude seems to be running loose? Here, I'll show you guys again. Look at that. So maybe it's not a trig function, which would be no. But okay, let's keep plotting. So negative 1, 1. Okay, what's that? 1.7. That's not a nice number.
here seems to be in half here, but something just after 1, 2, 3. Something just after 3, maybe 3.14.
And it's 0.
Next time it's on it, it's close to other whole numbers. Intersection with the x-intercept, but I almost want to look it up online. I feel like I'm so close to it. It's like something about the x's distance.
I feel like that's absolute value of x, and then something done to it. No, but then that would just be, okay, yeah, that could be something. Absolute value of a squared. Why do I have to end up adding a slider? I don't. I feel like if I didn't select it, it would be an average of all this, which would look like this.
Well, that's actually probably not. No, what's 0?
Maybe a is the exponent. Maybe it's 2 and a, like this. I'm gonna cheat. What makes a, what's this, a cosine graph wave increase amplitude? Is that simple? Just multiply by a? No, I don't think that's. No, see? What are you talking about? Amplitude increase as x increases. Oh! The frequency.
Is that true too? The frequency increases too here? I think the frequency. Oh, the frequency actually gets slower. Maybe it's radioactive decay. That's why I said watch out for the second one. Interesting. So both. I didn't think about that. The frequency also changes. It gets longer. Therefore, so the amplitude is increasing and the frequency is decreasing.
So I have to do two things. So this is decreasing. So it's not just a constant. Oh god, you're gonna make me get like this. Amplitude modulation. Inverse AT. Look at see, what? Okay, there's another one. Oh lord. See, this is there's too much. I mean, okay. I mean, I feel like there was a discussion of this maybe. Oh lordy. Oh my god, this homework.
Oh my god, this is doing 10 minutes. I think any pair of these graphs will intersect. Yes. Yes, it will intersect. What the hell is that? Yes. If yes, then estimate the x value. What do you mean intersect? Intersect as in the graphs cross once, then yes, of course. Bottom two graphs will cross at x equals -5 and 5, and much more. If talking, oh shit, I have 10 minutes talking about complete overlap, then no. Do you think that any pair of these graphs will intersect? Then no. They are completely. What? This is a question. Different graphs. Something to increase the amplitude as x is distance from 0 increases as well as increase frequency? No, decrease frequency. Actually, maybe it doesn't change. Look, well, it goes back. It does it, what, maybe 3 or 2? And then it does it like 5.5. Okay, maybe it doesn't. As well as the, so what, frequency, I should say period. I tried exponents and other variables. Hopefully they, like attempts in Desmos, to no avail. Okay. Oh boy, I'm so nuts. And I will take a look at my Desmos just for, oh fuck me. Oh, I might just link this video for that one. Like if they dispute it, I'll be like, look, I did the homework. I did it. Okay. Oh boy. The discussion looked, understandable too, which was nice. Wasn't being thrown in the fire. Now that it's cut off a bit. Okay, come on. Today. Yeah, okay, there we go. Share PDF. Oh boy. My email. Okay, that's sent over. Since I just finished it. Yeah, my bedtime is 8, and it's 11:54. Not very fuego. No, sir. Alright. I just swore that I already had the discussion pulled up. Oh yeah, here we go.
why did I want to go with this? What are quantities that are changing? Quantities are. No, I should have. Changing quantities or quantities that are changing. Blade position. I could be really specific. I could say blade X position, blade Y position. What else is changing? The speed? No, I think the speed is the same. Quantities that are changing. What else? Quantities and blade speed, blade radius, blade diameter, circumference of blade, cut, arc, right. Blade size, although not really relevant. Not relevant. Okay, how are they related to each other? Blade radius along constant changing quantities. X, Y position. You can say blade angle, blade radius along with angle helps determine X and Y position. If looking for it, yeah, that's good. Just grab a straight. For the connection to your question, let's give it a grab. How do you check your answer? From Pre-Calc 1, we were taught to do a variety of things. You might only need to do a few to get an idea of a function. Maybe you have to do all. Maybe one. Okay. Find X and Y, intercept. Find vertex if quadratic. Identify parent function of graph. Plot out various X and Y values. Identify asymptotic behavior. Oh shit, I need to. You know what actually fucked me is the not submitting that. Oh shit. Yeah, like that will actually fuck me. Because this just. Oh, come on, download, you fuck. Oh, this is taking me back to like high school when I would just cut it close. Just cut it close. Oh, I hope it doesn't do that 11:59 thing. Or sometimes when you submit 11:59. Fuck you. Sometimes if you submit 11:59, it'll actually mark it as late. Oh, God bless. God bless the Lord. I'm in Mountain Standard Time, and they're in Oregon. So I didn't think cameras would do that. I thought it would like, I'm not complaining. Nice. God bless. God bless America. Nice. Okay. Nice. Let's see if he submitted the right one. Or if it's just legible. Oh yeah, that looks good. Okay. symbolic behavior. I think I can put this away. And I just, okay. Oh, I can cross out the graphing activity and the week 2 discussion. Not too shabby. The last minute, but pickleball was fun actually. I play tennis, and so one, I'm worried it'll fuck up my swing because it's a shorter racket, obviously, and so those times I was missing the ball because I thought my racket was longer, and I was like, wait a minute, I have a paddle. But then once I get used to that shorter paddle, because I've done this before, then I swing a racket as if I have a paddle, so it messes up my swing. Plus the material's obviously different. One's a racket, one's a paddle. But it was fun. It was like such a vibe actually. It was so hot though. It's disgustingly hot. Just like, I wish summer just did not exist in terms of the heat. Just like, but yeah. It was fun though. It was kind of worth it. It's kind of worth this pain. I might not be saying that tomorrow though when I have to wake up for work, but cross that bridge when we get to it. Vertex, find it for up here. Identify degree. Identify degree ratio of numerator versus denominator if rational. Whatever. That's good. I'll just put X in it. Describe how would you check your answer? Using these, you construct a function and its function rule. If you see a graph, how do you determine its equation? How would you check your answer? Well, I don't have Desmos. Sounds like I'm on a test. You could just do what Desmos does. To check if given access to Desmos, you can type in your assumed function and see if it matches a given function graph. If not, calculate a few variables, negative, 0, and positive, and see if values match between your assumed function and given graph. Okay. Alright, let's see what the wise people. What did Boston Frey have to say? I like how he said as it relates to the origin. Any isotopes? I must be in the wrong class here. I shouldn't be shitting on these people. I haven't met any of them, but actually one of them, but they're probably nice people. But I just, yeah, I should. Power output that varies with the wind speed. I like how specific she's got. Angular velocity and rotational kinetic energy. I was in a physics class. I was first in a chemistry class. Physics class. No, that's true. Number of blades. Blade length. Blade radius, but not yet. And speed affects them. Damn, okay. So if we wanted to determine the equation of graph, we have to identify the equations this we put together. Okay, so she's doing like parent. It's just the coefficients based on intercepts and keypoints. Then we check the points and graph check. The function would have to start at 0 and increase in energy as you have stated. What the hell is he doing? difficulties I would be changing would be the angle measuring rate and the height above the horizontal diameter. Whoever's uses a formula. What? Did it tell us to? It didn't ask us to use I used a formula for the one. Oh. But it didn't say to construct a formula for the windmill. Oh, I guess how are they related? Is that what he's saying? How are they related? You know, that's fair. A function does tell you how its inputs relate to output. So, yeah, I'm gonna say that. I like that. Okay. I like how when the question asked, this sounds really passive aggressive. I don't know how this is gonna. I do. I like how he read it differently. God, I hope he's a viewer. That would help a lot in this situation. One of the 7 viewers. Actually, one video. I liked how you functions in the context of relating the constantly changing quantities. It hit home how universal functions are to model changes, relationships, etc. Thanks. God bless you, sir. Alright. Come on. Alright. What is all these people? Are all these people like engineers? This is pre-calc. Like if it was like calc 3, I'd be like, okay, but it didn't. It made me feel very dumb. I did not think that. Reduce mass of the blades. That's a. I like how it's nicely formatted. This is like a physics term, isn't it? Like the notation of that velocity. Okay. Oh yeah, I should have put that. Okay. What? They must have read it. I don't know, because they can't see it. Yeah, she was with me in Pre-Calc 1, so. Because if she was putting like power and stuff, I'd be worried. I like this one. Where is this? Oh, a lot of people probably. Oh my god. I tagged on. Hope you don't mind. God, this is lagging. Jesus. Oh shit. They aired. Oh god. Aired as a Actually, I think the air density would change. Wouldn't the speed through it? Yeah, I don't care. I do not care. Okay, I'd like input at angular velocity, electrical power output, and torque. Like how you plot in angular velocity, torque. Oh my god, torque and power. And power output. They were all real world examples, and I can see how when we really understand trig functions in circles, we could construct functions of our own to model in windmills, power output, etc. things. Output, God bless. They're all connected to model, etc. It's like it is with a. I think it is, right? You should know that. It's we have different examples that are given. Okay, what's that? Reply number 2. Come on. Come on. What is all these people saying? Oh, this is a person. Okay. Oh my god. With air pressure. Okay. Well, that's a little basic, but. Good lord. Good lord. Energy output. What? Is it really that simple? No way. I think he's an engineer. This guy's coming off engineer vibes. Oh, she must have read that. I feel like this is going to come in the learning materials. It's really a strange feeling. Like, I was telling the professor in the office hours, I didn't tell us. I tell him, I was curious about this type of, curriculum structure starting, but now I'm kind of on board. It's a lot. Well, I said it's a lot more work, but it seems worth it. Now I didn't say this, but this is what I meant by that, or this is more detailed of it. If I had the notes first and I studied it 3 times, like in 3 separate days for maybe an hour or 2, I feel like I would have the same imprint of it in my head that I do right now. Or by the end of me reading finishing this section, just one go through, really, you've seen it. Just me trying the problems and then doing the learning material like notes, I feel like it's the same. So, I don't know. You guys tell me. I haven't counted all the hours. If that's equivalent to 3 days of like 2 hours each day, 6 hours. Maybe I've done more than 6, but so. But it feels more imprinted, and I feel like I'm gonna remember it more. But anyway, okay. What is all these people saying? I guess windmill energy. That's where angular velocity. And maybe angular velocity is mentioned in the notes. They're all gonna say that. They're all gonna say that like that she wrote this, because that's what I'm gonna say. Horizontal phase shift. I got that one down. T's vertical shift. What'd you say A is? A is the amplitude, B is the frequency. Oh, interesting. BX. I was just putting. Oh, interesting. Yeah, I didn't include X. I included X out here, which does most shit itself. I don't think I put it in there. I don't think I did. Huh. Interesting. And, oh, interesting. Thank you for. It's so basic. Explaining the general form of sine and cosine equations to help construct the function from the graph. It really helped clear some confusions I had coming out of graphing activity 2. Thanks. Oh, mother. Oh. Just fucking kill me. Just fucking blow my brain up all over this computer. Just fuck. Oh god, this is the biggest deal I've had to deal with in years. Motherfucker. Fucking Christ. I don't remember what I said. God, sucker. Oh. Oh, bless you, Desmos. Would you like to? Yes. Oh. God bless. Last time I used Desmos, it was, Canvas, it was not this smart, so good on you for improving. Oh, you're good at 11:18. You know what? I am curious. I'm gonna do what you said I'm gonna do. I'm actually not that curious. Well, thanks for hanging with me, guys. And yeah, almost done with week 3. So good job. Peace.